Hi all, welcome to another video. In this video, I plan to explain to you how to solve integrals of the form sine to the power mx times cos to the power of nx. And as you can see, there are two problems out here, this and this one. The first problem, as you can see, has one odd and one even number as an exponent, and the second one has both even numbers. So the ways to solve these are very different. Let's start with the first one, and I'll tell you the hint and why we do what we do. The idea is that you have an odd number here. So no matter what, you have to split it up into sine square, then cos square, and then write another sign. For example, if you had sine to the power of 5, you would have written it as sine to the power 4x, and you would have written another sine x over here. There is a very simple reason why we do this. It is because we can now apply integration by substitution and enter u is equal to cos of x. When you enter u equal to cos x, the required sin x dx will be created. I will explain to you how this works. But before doing that, we need to write this in terms of cos as well, which can be done very easily by writing 1 minus cos square x times cos square x times sin x times dx. Now that you have all of it in terms of cos over here, this entire section, and you have a sin x dx over here, we can now take u is equal to cos x and begin. When you do du by dx, we get negative sin x. This is a direct formula that you know. Remember, we're trying to get sin x dx, therefore negative du, bringing the minus sign here, will become equal to sin x times dx. And when you now enter all of these in here, we get integral of 1 minus cos square of x can be written as u square, another cos square can be written as u square, and this sin x dx can be written as negative du times negative du. Now let's expand the whole thing. When you do that, you get u square times 1 is u square times u square is u power 4 times minus du. Now let's expand the minus as well by writing the minus in front like this. And when you expand this out, we get integral of u to the power 4 minus u square du, which you can now integrate using the direct formula that you know. U to the power 4, when you integrate, you get u to the power 4 plus 1 by 4 plus 1, and when you integrate u square, you get u to the power 2 plus 1 upon 2 plus 1, and then plus c at the end. So when you do this, you get u to the power 5 by 5 minus u cube by 3 plus c. And then now you can put u as cos x again, because that was the original substitution. So we get cos to the power of 5x by 5 minus cos cube x by 3 plus c, and that's the answer for this particular problem. So just to do a very quick review, if you have one odd and one even, no matter what, take one of those out. If you have sine to the power 5, you will write sine to the power 4 times sine. And this sign is what will get engulfed by the whole du. You know, it's going to be there for that particular reason, this sin x dx. So in this case, we had sine cube, so we wrote sine square times sine, and we proceeded solving it. I hope this one made sense. Let's now do the other one. Let me take this and let me open a new paint file and we'll try it out. So we are now doing integral of, integral of sine square x times cos square x dx. As you can see over here, both of them are even. So in this case, that particular trick does not work. You may be thinking, okay, what if we write one of them as cos and the other as cos? The problem is, if you write it as cos, then you cannot change the cos x in terms of sine, because cos x in terms of sine is root of 1 minus sine square, and this becomes very messy. That's why we avoid this particular approach. What we instead do is use double angle formulae. You might remember these formulae. Cos 2x is equal to 2 cos square of x minus 1. So solving, we get cos square x is equal to 1 plus cos 2x upon 2. You also know that cos 2x is equal to 1 minus 2 sine square x, because of which you get sine square x is equal to 1 minus cos 2x upon 2. So we input those values in here for cos square and for sine square. Now if you had sine to the power 4 and cos to the power 4, you would have basically taken this and done the whole square of that. Yeah. So when we do this, we get 1 plus cos 2x upon 2 times 1 minus cos 2x upon 2 dx. Now let's pull the 1 by 4 outside, times when we multiply 1 plus cos and 1 minus cos, we get 1 minus cos square 2x by using a plus b, a minus b formula. Now there's a small problem here. We have cos square again. We ended up getting another even exponent. Again, the same formula can be applied, but with a slight change. So we do that. We expand the integral. We put this 1 times dx, and then we create a separate integral for cos square 2x dx. And now what happens is, this can be solved directly. This is equal to x by 4. But for cos square 2x, there is a, you again use double angle formula. You know that cos of 2a is equal to 1 plus, cos of 2a is equal to 2 cos square of a plus 1. So here we have cos square of 2x. So take the a and replace 2x over there. When you do that, you get 2 cos square 2x plus 1, and on this side you get cos of 4x, because 2 times 2x will become 4x. Basically we are putting a equal to 2x over here. So simplifying this, we end up with cos, this was supposed to be a minus sign, I'm sorry about that. When you solve this for cos square 2x, we get 1 plus cos 4x by 2, which is what we substitute over here. 1 by 4 times cos square 2x will become 1 plus cos 4x upon 2 times dx. This will become, the 1 by 4 times 1 by 2 becomes 1 by 8 outside. 1 plus cos 4x upon times dx. And this will become 1 by 8. Integral of 1 is equal to x minus 1 by 8 times integral of cos 4x dx. Now I'm sure you know what's got to be done over here. When you have cos 4x dx, you know there is a, some of you may know the direct formula as sine 4x upon 4. But if you're not sure how to do it, you can always take v equal to 4x, dv by dx is equal to 4, and do the whole thing by substitution method. So when you do that, x by 4 minus x by 8 becomes x by 8 minus 1 by 8 times integral of cos v, the dx becomes dv upon 4. That's where the 1 by 4 sign comes from. So we get x by 8 minus 1 by 8 times 1 by 4 becomes 1 by 32. Integral of cos becomes sine v plus c. And finally you can put the value of v at the end. V was equal to 4x. So the answer for this becomes x by 8 minus sine of 4x upon 32 plus c. And this is how we do problems involving integral of sine to the power mx, cos to the power nx, where m and n are both even. Thank you for watching. I hope this made sense, and I will upload another video soon on this. Goodbye.